Hi everyone, I'm Kishore Vijay Abraham. Today I'll show a demo of running a standard NTB application like NTB NetDev on a host which is connected to an NTB controller which is implemented using multiple PCI endpoint instances. So this demo is based on version 7 of this patch series based on 5.9 RC5 kernel. My setup looks something like this. I have three EVMs. The EVM in the middle provides the NTB functionality. And for providing an NTB functionality, you need at least. So the EVM that I used here has DRA8 SoC, which has 4 endpoint instances. However, for this demo, I'll be using only the 2 PCI endpoint instances. So one endpoint instance is connected to one host and the other endpoint instance is connected to the other host with each other using the NTB system that is present in the middle. The internals of how I implement the NTB functionality using multiple endpoint instances is something I discussed in the Linux Plumbers Conference 2019, and I have provided the link to the presentation in the description. So with that introduction, we'll jump straight to the demo. So I have 3 panes here corresponding to the 3 EVMs here. So the middle pane corresponds to the EVM that provides the NTB functionality, and the panes on either side corresponds to the host EVMs. So let's bring up the NTB system first. Okay, so while this guy boots, maybe I'll give a brief explanation of what I'll show in this demo. So here I'll configure the center, the EVM in the middle, which is this EVM, using the stack that is actually shown in the bottom half of this slide. So here I am introducing a new function driver called PCI EPF NTB, which is used to configure the endpoint controllers here so that the transactions from one host can be routed to the other host. So the PCI EPF NTB by default, by design, is plugged into the PCI endpoint core framework. So previously, before this, we had only this PCI EPF test function driver. So the PCI endpoint core abstracts the different endpoint controller drivers. So the EVM that I used here, the DRA8 EVM, has cadence IP. So here it will use the PCI cadence driver. So if you have already worked on the PCI endpoint core, you know that in order to configure the PCI EPF test, we use the config.fs file system. So similar to PCI EPF test, here also we'll be using the config.fs file system to configure the NTB function driver. So one of the initial versions were actually using device tree to configure the PCI EPF NTB, but based on the review comments, this has also been moved to be configured using the config.fs. Okay, so this guy has right now booted. So I'll actually show in this demo how I use config.fs to configure this PCI EPF NTB. So before getting into the details, the endpoint instances that is used in DRA8 SoC actually supports 6 physical functions. So what I'll show is I'll configure 5 physical functions with the NTB functionality and 1 physical function with PCI EPF test functionality, so that we can be sure that adding a new function driver does not break the existing PCI EPF test function driver. So as I mentioned, we use config.fs to configure the endpoint function drivers. Okay, so the PCI endpoint core creates the PCI EP directory under the config.fs file system. So it will have 2 directories, the controllers and functions. So the controllers directory will have list of all PCI endpoint controllers that is present in the system. So here I have configured two endpoint controllers or two PCI controllers in endpoint mode. So that's why I see two entries inside the controllers directory. And the list of all the function drivers that is supported in the system will be listed in the functions directory. So right now we have this PCI EPF test, which was existing from a long time, and then you have this PCI EPF NTB, which is actually introduced now. So the first step in order to create an NTB function device is to create a directory inside this PCI EPF NTB directory. So what I'll do is I'll do this. So here, okay. So the first step here is to create an NTB function device. So in order to do that, I will create okay, so I created, okay, let me just expand this. So now I created a new directory called func1. So when a user creates a func1 directory, what it will do is the endpoint framework will create an NTB function device, since this directory is created under the PCI EPF NTB directory. So the PCI endpoint framework will also populate the directory that is created by the user with some of these fields which can be configured by the user. So most of these fields are used for configuring the standard configuration header space. And there are also other entries like the MSI interrupts and MSIX interrupts are used for configuring the MSI and MSIX capability. So the user can populate these fields. For instance, the user can populate the vendor ID and device ID so that on the host, this device is being detected from a particular manufacturer. So I have already written a script for configuring all the functions. So as I mentioned, the first step is to mount the config.fs file system, create a directory under the PCI EPF NTB directory. So what this will do is this will create an NTB function device. If the user likes to create a EPF test function device, then the user should create a subdirectory under PCI EPF test. So right now we have only these two function drivers supported, and then the user should populate the entries that is created by the endpoint core. So as I mentioned, here I am populating the vendor ID and device ID so that the host detects this device as a TI device. And then so these fields are like standard entries which is common to all endpoint function drivers, but there can also be configurable fields that are specific to a particular endpoint function driver. So here there could be, for instance, here there could be like certain fields that is specific to an NTB function driver and which should also be configured by the user. So in order to do this, the user should create a subdirectory under the func1 directory. So here I am creating a directory named NTB under func1. So when the user creates this directory, the NTB function driver will populate it with entries for the user to configure. For instance, it will create a DB count entry, a scratchpad count entry, the num memory windows entry for the user to configure. So maybe I can just quickly show. Okay, so in order to configure parameters that is specific to NTB, what I have to do is I have to create a subdirectory. I'll use the same directory so that okay, so that the script will not fail. Okay, so what I did here is I created a subdirectory under func1. Okay, so when I create a subdirectory, the NTB function driver will populate or it will create entries which has to be configured by the user. So as I mentioned, it creates entries so that the users can specify the number of doorbells that has to be supported, the number of scratchpad registers that has to be supported, the number of memory windows, and then all this MW1, MW2, MW3, MW4 are entries where the user can specify the size of each of the memory windows. So here I am populating I'm configuring the NTB device to support 4 doorbell entries, 128 scratchpad entries, and 2 memory windows, and I'm also specifying the size of each of the memory window as 1 MB. So after I do this, I have to I have to bind the NTB function device with endpoint controller. So in a normal case where, say for instance, a PCI EPF test, the communication is between only the 2 devices. So if I'm configuring this endpoint controller to be used for PCI EPF test, then it has to be bound only to one endpoint controller. But in the case of NTB, where it involves communication, facilitating communication between 2 hosts, it needs 2 endpoint instances. So NTB is a special case where you have to link or bind the NTB device with 2 endpoint controllers. So that's why you see me creating 2 soft links, one for one endpoint controller and the other for other endpoint controller. So the soft links are created under the primary and secondary directory that is created by the endpoint framework. So here, some things to note is there is really no restrictions on what names you provide for the subdirectories. All you have to make sure is you have to create a subdirectory under the PCI EPF NTB directory. Other than that, there is really no restrictions. And then there is also no restrictions on which endpoint controller should be bound to primary interface and which endpoint controller should be bound to the secondary interface. It will absolutely make no difference in the functionality, even if we swap these endpoint controllers, this for the primary interface and this for the secondary interface. So for configuring one endpoint function to provide the NTB functionality, I have to do these many steps. So as I mentioned before, this the endpoint instance that is present in this DRA8 supports 6 physical functions, and I am configuring 5 physical functions to provide the NTB functionality. So here I am configuring 1 physical function, and similarly I am doing the same set of steps to configure 5 physical functions to provide the NTB functionality. So here I am creating a new directory func2, which means it will create a new NTB function device. Then I'm populating the standard configuration parameters. Then I create a subdirectory under func2 so that I can configure NTB specific parameters, and then I populate the fields created by the NTB function driver, and then again I create soft links, 2 soft links for this endpoint function device. So here I have only 2 hosts which are used for communication. So and all the 5 functions I'm configuring it to enable communication between only these 2 hosts. But say if you have another host, say if I label it A and if I label this host as B, and I have like another host C, which is then connected to a different endpoint controller. So just like we facilitate communication between the host A and host B, we could as well facilitate communication between host A and host C, an imaginary host that is connected here. labeled C. So in order to do this, all I have to do is I have to bind an NTB device with this with the endpoint controller that is connected to this host. So which would mean instead of using this, sorry, which means instead of using this same, instead of creating this same soft links between the two endpoint controllers, I will instead of this, I will use a different endpoint controller which is connected to the host C. Right, so once I do this, that particular NTB function device will actually facilitate communication between the host A and host C, just like how we facilitated communication between host A and host B. So I do the same set of steps to configure the 5 physical functions, and then the last physical function I create an EPF test function device. So this is just to make sure that while adding this PCI EPF NTB, I am not breaking any of the functionalities that is provided by the PCI EPF test. So the first step, like before, is to create a subdirectory under the PCI EPF test. So what this will do is this will create an EPF test function driver, and then similar to before, I populate it with fields to indicate that this particular device is a TI device. And then I also populate fields like MSI interrupts and MSIX interrupts. So I configure it both with 16, so that the endpoint controller configures is configured, the MSI capability and the MSIX capability in the endpoint controller is configured to provide 16 interrupts. So here I have like 5 physical functions, which uses actually physical function on both these endpoint controllers for the NTB functionality. So there is one physical function on this endpoint instance and one physical function on this endpoint instance. So that's why I do this twice. So for the PCI EPF test, it is really bound only to one endpoint controller. So that's why you see I'm creating only one soft link when I use PCI EPF test function driver. So here I'm trying to configure the last physical function of both these endpoint instances to provide the PCI EPF test functionality. So this one provides the EPF test functionality of the last physical function of this endpoint instance, and this last set of sorry so and this last set of steps actually configures the last physical function of this endpoint instance with to provide the PCI EPF test functionality. So once I do this, I will give start to both these endpoint instances so that both the endpoint instances are ready to establish link with both these hosts. Okay, so this explains how I actually configure use config-fs to configure both the PCI EPF test function device and the PCI EPF NTB function device. So all this information is also present in the Linux kernel documentation. You can just go and refer this documentation PCI endpoint PCI NTB how to.rst file. Okay, so now that I have explained what I do in the script, I'll just go ahead and run the script that I just showed. Okay, so this I just for demo I created this subdirectory, so you get small warnings here, but this shouldn't affect any of our demo stuff. So now that I have executed this script, the endpoint controllers, both these endpoint controllers is like fully configured. So as I mentioned, we have like so both these endpoint controllers has like 6 physical functions, and we have configured 5 physical functions to provide the NTB functionality, which facilitates communication between these two hosts. And the 6th physical function of each of these endpoint instances is configured to provide the PCI EPF test functionality. Okay, so now I'll go ahead and bring up the other host. Okay. Okay, so while this host comes up. So just now we saw how we used the endpoint side framework to configure the NTB system. So on the host side system uses the standard NTB framework that exists in the Linux kernel. I am just adding a small NTB hardware EPF which communicates with the PCI EPF NTB on the endpoint side. So what this will help is to use the standard NTB applications, which is already existing in the Linux kernel, and it is also used by other NTB vendors to be used with an NTB controller that has been configured using the PCI endpoint framework. So in this demo, I'll be showing how I use NTB NetDev, which actually exports an Ethernet interface for communication between these two hosts. But any of these NTB applications should work as well fine. Okay, so this both these hosts has booted up. Okay, so I'll do an LSPCI. So the LSPCI shows it has detected the NTB device that we have configured. So here there are, like, since we have configured 5 physical functions to provide NTB functionality, you see 5 devices having their class as RAM memory. The last one, which provides the PCI EPF test, has an unassigned class. Okay, so I will have to use these modules: NTB hardware EPF, NTB transport, and NTB NetDev in order to create an Ethernet interface and also to facilitate the communication using this NTB controller. So I have a script which does that. So what I do here is I just load all the required modules. So as soon as I do install this NetDev, it will create an Ethernet interface for each of the NTB devices that's been detected. So what I do here is I assign an IP address to each of these Ethernet interfaces. So by default, I have one Ethernet interface, which is an actual Ethernet interface, which is connected to a router. But after this, I will have like 5 virtual Ethernet interfaces to communicate with the other host. And I'm also trying to assign an IP address for each of these Ethernet interfaces. Okay, so I'll run this. Okay, so this has created 5 Ethernet interfaces. Okay, so this has created 5 Ethernet interfaces, and each of these interfaces are also provided a unique IP address which can be used for communication with the other hosts. So I'll do the same step again here. Okay, so here also I could see it has detected the NTB devices. So I see 5 entries for NTB device and the last entry for PCI EPF test. So similar to what I did here, I have a script which actually loads all the required modules and also assigns an IP address to each of the Ethernet interfaces that gets created by NTB NetDev. So I have given an IP address that ends with .1 on the second host and .2 on the first host. So what I'll do next is to do a simple ping test, which communicates to and corresponding Ethernet interface on the other side, on this side. So I'll do a ping from this system so that it reaches an IP address that ends with .1. Okay, so here again I will run the script. Okay, so the link is ready, and so here as well I was able to see that it has created all the Ethernet interfaces, and it has also assigned an IP address to each of these Ethernet interfaces. Okay, so next I will run a small ping test. Okay, let me just show this. sorry. Okay, so this is like a simple script which actually sends 10 packets to the other host, which with all the IP addresses that ends with .2. Okay, so I just run this here. Okay, so I could see the ping has started to work fine. So I'll do the same thing from here also. So I have a similar script here, which actually sends 10 ping packets to the other host. So as you can see, I ping to an address that ends with .1. Okay. Okay, so this as well is running fine, which means ping to the other host seems to work fine. So it will send ping to each of the 5 other Ethernet interfaces. So here I am communicating between these 2 hosts, but as I mentioned before, you could as well have a different host and you could do a ping test with the other host. Okay, so this ping test has completed. So has been received. So this is like a simple test. You could as well run an iPerf test or do a ping test with an infinitely large number of packets. Okay, so this guy has also, here also I don't see any packet loss. So this also looks fine. So we have like verified that the NTB functionality works fine without any issues. But we have also configured one physical function to provide the PCI EPF test functionality. So let's go ahead and test that as well. So I'll first do first install the PCI endpoint test. Okay, so I could see that for the last device, last physical function, the PCI endpoint test is bound to it, whereas for all the other devices, an NTB hardware EPF device is bound. Okay, so the PCI endpoint test actually creates a device entry which can be used by the PCI test user space utility to perform the various tests. So I will just run. Okay, maybe since I Okay, so I will use this PCI test utility to perform. Okay, so the read test succeeded, the write test succeeded. I'll also do with DMA. Okay, so I could see that all the tests, all these are like simple tests which perform basic read and write test, and we could see that all of them works fine. So the NTB system where we have configured the PCI EPF test throws out some prints. This is basically for the profiling information. This is not really the scope of this demo, but it just shows that the transfers take place using this NTB device. Okay, so similarly, I'll do the same test here. So as you could see, the PCI endpoint test is bound to the last physical function, whereas for all the other devices, an NTB PCI driver is bound. So similar to the other host, I'll just do a simple read-write test. Okay. Okay, so here as well, all the read-write test passes. So this kind of like completes our verification. So we were able to see that the PCI EPF NTB, with PCI EPF NTB, we were able to use the standard NTB NetDev application to communicate between these 2 hosts. And we also tried to use the PCI EPF test for communication between the host and the endpoint, and similarly the other host and the endpoint, and we could see that that as well works fine. So this actually makes this actually confirms that adding the PCI EPF NTB does not cause any regressions with PCI EPF test as well. Thanks everyone for watching this video.